In this video, we're going to be discussing medication calculation questions. In this video, we're going to discuss some general terms that you need to know. We're going to look at the formula for medication calculations, and we're going to do a couple example questions, and we're going to take it really slow and really explain some of the common areas of mistakes. So here are some of the terms. First of all is the route. And the route is basically how the medication is entering the body. Is it PO by mouth? Is it IV or intravenous? Or is it topically, like Voltaren, putting Voltaren on a knee or something? The next medication, or the next word, I guess, is medication. And medication is the actual compound that is completing the desired effect. It seems simple, but some people get that mixed up. And we're going to discuss that later on. So the dose. The dose is how much of this medication is being administered. And again, keeping that in mind, that's going to make more sense in the coming slides when we do the practice questions. Final one is one that people often have trouble with, and that's the vehicle. And so think of what a vehicle does in real life. When you think of vehicle, you think of a car, and a car takes you from point A to point B. In medication administration, it's kind of similar because this is the way the medication is available, and this is going to make sense in the coming slides. So let's take a look at the formula. So the formula has three parts. The first part is right here, the desired dose. And the desired dose is, for example, the patient needs 250 milligrams of metformin. So the desired dose is going to be the 250 milligrams because that's what the patient needs. The on-hand dose is a little bit different. It's what the medication comes in, like the actual dose, what the dose comes in. And this can be a little bit complicated, but we're going to run through it in the next slides. Next up is the vehicle. So how is this medication being delivered to the patient? Is it through a liquid? Is it through a tablet? And just like this text box says, it could be a tablet, it could be a specific concentration of liquid. This is all going to make a little bit more sense in the next slide, as long as you have a general idea that it's what you want divided by what you have multiplied by the vehicle. That's going to give you the amount you have to give. So let's run through some practice questions and really see how this works. So practice question number 1. Patient is ordered 500 milligrams of metformin PO TID. Metformin is available in 250 milligram tablets. How many tablets do you give the patient? And again, some people are going to be able to look at this and immediately know the answer, but we're going to run through how the math works, and then you're going to be able to apply it to any question you get. So what's the first part of our formula we have up here? It's desired dose. So what's our desired dose? Let's take a look at the question. A patient is ordered 500 milligrams of metformin. That's what the desired dose is. So we're going to put that right up here. The next one. What's the on hand? So let's take a look at the question. Metformin is available in 250 milligram tablets. So they don't have any 500 milligram. They don't have 500 milligram tablets. They only have 250 milligram tablets available on this floor. So we're going to highlight that, and then we're going to put that at the bottom. So the on hand is 250 milligram tablets because that's all they have available. And now what's the vehicle? This one, the vehicle is not as important because it is tablets, and obviously we can just put one tablet because 250 milligrams in one tablet. So how many tablets do you give the patient? So let's basically all you have to do at this point is solve this math question. So 500 divided by 250 is 2. And if you want to pay really close attention to the math, the milligrams are going to cancel out, so you're only going to be left with 2. Your dose is never going to be, your amount to give is never going to be in milligrams. It's going to be a unit of your vehicle, which is this. So tablets. So we're going to have 2 multiplied by 1 tablet, or tablets, because obviously the vehicle, the way we're calculating it is 250 milligrams per tablet. And what's that going to give us? 2 tablets. Of course, that makes sense. And now let's go double check this in order to make sure. We're going to multiply 2 tablets by what we have, by our on hand, which is 250. So 2 times 250, and that adds up. It gives us our desired dose. That's how you back check it. So practice question 2A, and these next 2 questions are going to be very similar, but I'm really going to show you something very important. A lot of people get this wrong. So let's run through the question like normal. A patient is ordered 50 milligrams of Dilantin, PO/BID. And again, the PO/BID is not really relevant to the medication calculation at this point. It's just telling you how you're going to be giving it and how often you're going to be giving this dose. So the unit only has the drug available in 125 milligram per 5 milliliter concentration. So obviously this is a liquid that you're going to be giving a patient by mouth, because it's a PO/BID. So PO means by mouth. This is what the question is saying. Now let's take a look at this. This is the most important thing you have to remember. A volume is not a dose, and these next 2 questions are going to kind of explain that to you a little bit better. So this 5 milliliters that you see here, it has absolutely nothing to do with the dose. The dose is always in milligrams, or a unit of weight. This is, milliliters are a unit of volume of liquid. It has nothing to do with the desired dose we are trying to achieve. So let's run through the question and see what we get. So we're going to start with the desired dose. So the desired dose is what the patient has ordered. So patient is ordered 50 milligrams. So we're going to put that right at the top. And next up, we're going to put the on-hand amount. So the on-hand amount is this part right here. 125 milligrams is what you have on hand. And remember, we're not putting the milliliters here because that's not a dose. That is a volume. So we put 125 milligrams down here. Now, the vehicle. The vehicle is a little bit different than the last question we did, where it was just simply tablets. Tablets or capsules, that's an easy way of doing it. But this is milliliters, and that's what we're going to put. Under vehicle, under this vehicle section where we multiply by the vehicle, we're going to put 5 milliliters. That's where this 125 milligrams is in the 5 milliliters of fluid. So now let's do this math and solve this question. So 50 divided by 125 equals 0.4. And we're going to multiply 0.4 by the vehicle, which is 5 milliliters in this case. So we're going to multiply it by 5 milliliters. And again, if you're paying close attention to the math, these units have canceled. They will always cancel. So 0.4 multiplied by 5 gives you 2 milliliters, and that's going to be the answer to this dosage question. So you're going to give the patient 2 milliliters of this fluid in order to give them the 50 milligrams that is ordered. And again, we can double check this. Just how we did in the last question, you can double check it. So now this question is almost identical to the last question. So the patient has ordered 50 milligrams of Dilantin PO/BID. Again, this is what the patient has ordered. The unit only has the drug available in 125 milligrams per 10 milliliter concentration. So that this part is the same, but this part has changed. And now look, this is just the vehicle that has changed, and the actual dose that the patient required, it's exactly the same. Nothing has changed at all. So let's run through this question and see how much of a different result we get. So the desired on hand, obviously the same as last time, 50 milligrams. The amount we have on hand, which is 125 milligrams. Remember, not a volume, it's the actual dose, the weight, the amount of the medication. And then we're going to multiply that by the concentration, which is, or not the concentration, but the vehicle. The vehicle in this case is 10 milliliters instead of the 5 milliliters we saw in the last question. So this is our formula, and then we just solve it. So 50 divided by 125 is 0.4. Once again, nothing has changed. But we're going to multiply that by 10 this time. And then we're going to get, the answer is going to be 4 milliliters. 4 milliliters, but the patient has ordered the same amount as last question. In the last question, it was only 2 milliliters. So this question kind of gives you, an explanation for that the different concentrations that the medications come in really do matter, and you really do have to separate in your mind the actual weight or quantity of the medication itself and the vehicle it's being administered through. Last question was 5 milliliters. This question is 10 milliliters. The patient's ordered the same amount, but you have to administer a different amount because the concentration is very different.